Hi everyone, my name is Nina and my project is on lithium protective membranes for high energy density batteries. So lithium ion batteries are everywhere today in our phones, in our laptops, and even in most electric cars. But the maximum range of a commercially available electric car today is about 300 miles. Most are much less than that, but the maximum is about 300 miles, which I think is amazing. But to achieve that, the battery pack required is weighs over half a ton, and that's because the energy density of lithium ion is around 300 kilowatt hours per kilogram. The energy density of petrol is over 11,000 kilowatt hours per kilogram. So how do we bridge that gap and maybe make electrifying other forms of transport possible? Well, I think we're going to need to look beyond lithium-ion batteries, and my research is on next-generation batteries, which use lithium metal as one of the electrodes, rather than the kind of insertion compounds that some of the other speakers have discussed. So this is just a schematic of a lithium oxygen cell. So lithium oxygen cells have the highest theoretical energy density of any system. So as I said, they use a lithium metal at one electrode, and this reacts with oxygen at the other electrode to release energy. And this has the kind of big advantage that you don't have to carry the oxygen around in your battery. You can take it from the air, which gives you a big weight saving in theory. Unfortunately, when the lithium and oxygen react, they do form a solid product, which is inside your battery until such time that you recharge it, break that product down and release the oxygen again. Even accounting for that, the energy density in theory of lithium oxygen batteries is 10 times current lithium ion technology, and about a third as energy dense as petrol. So why aren't we using lithium oxygen batteries right now? Well, luckily for me, because it means I get to do research, there are some technical barriers to overcome. One of them is that the solid product that forms on discharge is electrically insulating, and it basically clogs up the electrode as you discharge, limiting your capacity. Another problem is that you have to apply quite a high voltage to break it down again when you recharge the battery, and that reduces your energy efficiency. But there are ways around this. You can add redox mediators to kind of help these reactions, which are kind of soluble catalysts. But every silver lining has a cloud. Because the redox mediators can react directly with the lithium metal electrode if they're in direct contact with it. Sorry, a little animation. Yes, mediators. But one way, so you need a way to protect the lithium. Dear, I'm well over time, sorry. To protect the lithium, and one way to do that is to use lithium ion conductive membranes, which are membranes which let lithium and only lithium pass through them. So obviously, it should be fairly obvious that the main performance criteria for those membranes are good lithium ion conductivity, giving low resistance, and good selectivity for lithium, or in other words, low permeability to other species, including mediators. And most of my research so far has been developing experiments which measure against those criteria. And I'll just leave you with some of the results, which I think is quite a pretty graph. So this shows you the unique electrochemical signature of a particular redox mediator gradually appearing over time as it permeates through, in this case, not a very good membrane, lithium protective membrane, but hopefully working with collaborators who are going to provide some other materials which perform better, will identify something that can take lithium and oxygen a step closer to delivering on its promise. Thank you.
George can share. What kind of support do you use on the air side?
On the air side, so that's like a sort of carbon foam, typically, which is the sort of site for the oxygen reduction reaction.
You mentioned lithium air. What about, is it also applicable to, say, lithium sulfur or the other solid state technology? So it's basically a technology for lithium passivation.
Lithium protection.
Yeah.
Yeah. I mean, you would have to kind of assess separately for permeability to lithium polysulfides, which are the issue in a lithium sulfur battery. But yeah, it's the same idea.